Good day everyone. Today we're going to be coding the selection sorting algorithm from scratch in Java. It only takes a few lines of codes, so it's a great programming exercise for beginner programmers. But first, it's a good idea to talk about exactly how the selection sort algorithm works. So let's say you have an array of integers like we have here. The job of the selection sort algorithm or any sorting algorithm is to put these elements in their natural order, which per integer is going to be least to greatest. So let's look at this set of integers as an example. So we start at the first position here, and we're going to do is search from this point of the array all the way to the end and remember the index of the smallest number that we find. So we do that starting at 4. So the current lowest number we've seen is 4. And then we look at 5. As 5 less than 4? No. So 4 is still the lowest that we've seen. And then we move on to 1. Is 1 less than 4? Yes. So now 1 is the lowest number that we've seen. And we move on to the 2. Is 2 less than 1? No. 1 is still the lowest number and move on to the 3. Is 3 less than 1? No, 1 is still the lowest. So now we've gotten to the end of the array and we know that the number 1 is the lowest number that we saw. So now we're going to do is swap 1 to this first position that we're looking at. So we put 1 over here and 4 over here. So now we know that 1 is the lowest number in this entire array and that this 1 is definitely in the right spot. Next, we do the exact same thing but we start at the next position in the array. So we're looking at 5. 5 is the current lowest number we've seen. And then we move on to 4. 4 is less than 5? Yes, so now 4 is the lowest number we've seen. Then we move on to 2. Is 2 less than 4? Yes, it is. So now 2 is the lowest number we've seen. And then we move on to 3. 3 is not less than 2 and we've now reached the end of the array and 2 is the smallest number that we've seen. So what we're going to do is take this 2 and swap it with that position that we started at. Then we know that the 1 and 2 are in their proper position and we can move on to the starting with this next position and we do the exact same thing. We start here and find the lowest number. So we start at 4. 5 is not less than 4. 3 is less than 4 and we're at the end of the array. So we do the swap again by putting 3 here and 4 here. And now we know 1, 2, and 3 are in the right position. And we move on to the next position in the array. So we start at number 5. Is 4 less than 5? Yes, it is. We reached at the end of the array and 4 is the lowest number that we've seen. So now we swap these 2. Now, once we're looking at the very last number of the array, we know that there's nothing past it to switch with. So we know that it's automatically already in the right place. So that's it. We're done. We have the array of integers in the correct natural order. Now, let's take a look at the Java code that implements the selection sort algorithm and the main method. First, we have a selection sort method, which is responsible for sorting the array. And this is how you do it a selection sort. Public, static, void, selection sort, pass in int, we call it r. Now let's break down the outer loop. For int I equals 0, I is less than r dot length minus 1 I plus plus. This loop iterates through each element in the array up to the second to last element. Now, let's explore the inner loop within the selection sort method. Just type int index equals I. For int j equal I plus 1, j is less than r dot length j plus plus. The inner loop starts from the next element after the current outer loop index. It searches for the lowest index in the unsorted part of the array. Within the inner loop, we compare elements to find the smallest one. This is how we do it. If r pass in j is less than r pass in index and braces. In this step, if we find an element smaller than the one at the current index, we update our index variable to the new, smaller index, and close it, braces braces. Now let's move on of how to swap or change position the elements. After finding the smallest element in the unsorted part, we swap it with the element at the current outer loop index. Just type int smaller num equal r index. Next, r index equals ri. Next, ri equals smaller number. Here, we use a temporary variable smaller num to facilitate the swap. This ensures that the smallest element is moved to its correct position in the sorted part of the array. And we're done to selection sort algorithm. Now moving on to the main method, where we initialize an array and display it before and after sorting. And we're going to make an array of integers, int, and we call it r1. 9, 14, 11, 59, 100, 67, 7. Inside of this array, you can type any number and how many you want. It's up to you. We're going to print out the arrays of integers. And you can write inside like before selection sort. And then in the bottom, for inti colon r1. Printing again, system.out.print I plus quotation. And let's try to run it to see if the arrays of integers are going to show. And you can see here in the output the unsorted array of integers. Now, we're going to call the selection sort to sort the arrays of integers we put. System.out.println, then remove the quotation. We need this to show and display the sorted arrays of integers. Now we're going to call the selection sort that we put earlier in the top of the code. To call it, just type selection sort. Parentheses R1. Now print out the sorted array system.out.println. You can type inside again. After selection sort. And then in the bottom, for inti colon r1. Then print out again system.out.println I plus quotation. This section sets up an array, which is the r1, prints it before sorting, calls the selection sort method to sort it, and prints the sorted array afterward. And now we're going to run it. And that's it. As you can see in the output, we have before selection sort with unsorted arrays of integers, and after selection sort with assorted arrays of integers. And we're done. That's how you do the selection sort algorithm in Java. This is the end of the video, so subscribe!